Network Dojo.
Now we're going to get into the actual configurations of multicast, and we'll start with the most basic method of RP assignments, and that's static RP assignments. But even before we get into that, I'll just preface this video with the rest of the configuration of getting multicast enabled in PIM everywhere, since that's a pretty small part of the configuration, or at least it's a pretty simple part of the configuration. So static RP assignments, the nice thing with static RP assignments is they're very simple, they're very easy to configure. It's just that you need to configure them on every single device because they're statically configured. Now in the lab, there's only a handful of devices that would ever have PIM enabled, so it's not that big of a deal. In a real network where you might have hundreds of devices, yeah, that becomes kind of a pain, and you'll probably look at a different method. But this is a very easy method to configure, and since there's so few devices, we can whip it out pretty quick. The important part is just that whatever you configure on one, you configure it on all, so that everyone's in agreement as to what the RP mapping is going to be. Now, we could either just have one RP in the entire environment, and it's the RP for every single multicast group out there, or we might be asked to start doing multiple RPs, or limiting the scope of which groups map to a particular RP. And when we do that, we use ACLs to limit the scope. So we'll see that we basically use permit statements in an ACL, and if an ACL permits it, then that is the RP involved. So as we define the RP mappings, we would reference the ACL, and that's how we tie a list of groups to a particular RP. And again, if we want to do that, no problem. We just need to replicate everything, including the ACL, on every single device, and then everyone has the exact same configurations. So this is what's going to allow us to potentially have more than one RP active at a given time. Because there's kind of a rule of thumb with multicast is that for a given RP, for a given multicast range or IP, we can only have one RP for it. And so, for instance, let's say that I want to have an RP for multicast groups that start 239.x.x.x. That's fine. So we can have an RP for any 239 addresses, and then I can have another RP for every other address. And since they're handling different ranges of multicast groups, that's fine. They can both be active at the same time. Everyone uses RP1 for the 239 addresses. Everyone uses RP2 for every other address, and everything works the way that we want. It's just I can't have two active RPs both servicing 239.x.x.x without doing something fancy like a protocol that we don't have to worry about in the network here. So as long as there's one RP for a given multicast group, we're good to go. And we can have multiple RPs as long as they're for separate groups. So that's fine. But there's a decent chance where maybe we just have one RP, it's the RP for everything, and it's a very simplistic design. So before we get into that configuration, let's go to my topology. Here's what I'm working with. So same topology that we have for the unicast routing. I already do have unicast routing fully configured on CATs 1, 2, and 5, so that was that first step in the magic formula. So I'll go ahead and I'm going to enable multicast globally on all these devices because it's not enabled by default. I'm going to enable PIM Sparse Mode on every layer 3 interface of every one of these switches. That's step number 3 in the magic formula. And then we'll show you the RP configurations after that. All right, so I believe my switches just finished their reboot. They're finishing coming up right now. But if we look at our routing, we are learning things. EIGRP is our routing protocol, but we're fully working on the unicast front. So I should be able to go to turning on multicast. If I could spell multicast. IP multicast routing, enter. Turns on multicast at a global level. Repeat this on all layer 3 devices. And there we go. If you want to check it after the fact, show IP multicast will tell you if it's enabled or not. Easy enough. Next step was to enable PIM on all layer 3 interfaces. And to do that, we have to do a per interface configuration. So just like where we had it in IPv6 routing protocols, where we had to add every interface with a piece of config, Same deal with PIM here. So use the same process that I showed you with your IPv6 routing, where you do a show IP int brief. This lists out all of the interface names. You grab those names. You pop it into here. Now, actually, I already did this from a previous attempt at this video. And I do a find replace, find VLAN, replace it with interface VLAN. VLAN, not version. And then the command to add an interface into PIM with sparse mode is Ipm Sparse Mode, as you can see here. So paste this into every single interface. The other modes would be dense mode or sparse dense mode. Again, we don't have to worry about those modes. So just plain sparse mode. Select all. Paste it in. And then repeat this on every single layer 3 device. So Cat2 has a similar list of VLANs. It also has one extra VLAN that I forgot about elsewhere, but it has VLAN 116 on it for some reason that I didn't take off. And then we have our gig 1020. Now I'm taking a little bit of a shortcut because I'm familiar with my environment, but in the lab, use that method on every single device just to make sure you don't miss anything. Here are my interface names on Cat5. And yes, even loopbacks, just any layer 3 interface, just put it on there because you can't go wrong if you add it. You can only start going wrong when you start taking it away, unless they actually tell you to take it away or not put it on there. Let's finish getting this. And again, the command, Ipm Sparse Mode. PIM, thank you, spell check. Paste across the board. Select all, copy, paste. All right, so now I have PIM everywhere. I've got multicast enabled, I have unicast enabled, so I've completed steps 1 through 3 of my magic formula, patent pending. Let's take a look at this. Show IP PIM interface. Here's every interface that has PIM enabled on it. It should be an identical list of interfaces that have layer 3 addresses on them. And we can see in this column here, S for sparse mode. If you see SD, that's sparse dense mode. We probably don't want that. And then the version is always going to be version 2 here. That's fine. We don't have to worry about that. And so here we go. We have it up. And we can see that we're actually forming PIM adjacencies because we have a neighbor. We have one neighbor on every single interface. That's what all those logs were for too. We're forming PIM adjacencies on these interfaces. So just like routing protocols have adjacent, unicast routing protocols have adjacencies, PIM does as well. So as long as we're using sparse mode on both sides, they can talk to each other. They'll form an adjacency. What about Cat5 here? Show IP PIM interface. Sparse mode across the way, I only have one adjacency because that's the only interface I have something on the other end connected to with PIM on it. So there we go. We are all set with the exception of getting that RP assignment configured. So that's where we're going to spend really the bulk of every video beyond this for multicast routing is all about defining the RP. Because there's a number of different ways to do it, some of them more involved than others, some of them more advanced than others, but this is where we're going to spend most of our time, honestly, looking at that RP assignment process. So we'll start off with the most basic method of all. One RP address, one RP is the RP for every single multicast address using a static mapping. Okay. The command IP PIM RP-address, and then what is the IP address of the rendezvous point? So I'm gonna choose Cat1 as my RP. And so what I need to do is I need to pick an IP address of one of my interfaces. That interface absolutely must have PIM enabled on it, but we've enabled PIM everywhere, right? So we don't even have to worry about that. So I'll pick its VLAN 102 interface, which is this IP address right here. So I'm saying, with this command, the RP address for every multicast group, because I haven't called out an ACL, is 10.0.2.11, which happens to be one of Cat1's IP addresses. Now, I must replicate this on every device, because everyone needs the same RP mapping. And we'll see that after the config's done. So IP PIM RP address, that IP address. IP PIM RP address, that IP address. So anything that has PIM enabled on it somewhere needs the RP mapping. Let's look at the RP mapping. Show IP PIM RP mapping. And so what we're going to see is for the multicast group 224.0.0.0/4, which is every multicast group ever, it goes all the way through 239.x.x.x. We happen to have a static mapping, but the method's fairly irrelevant. What we're looking for is the group to RP mapping. So this group maps to this RP address. And this happens to be the only mapping that I have. And so for everything, Cat5 is going to talk to 10.0.2.11 as the RP. And what we want to see is that this group to this RP IP address is identical on every single device. So I'm going to go to Cat2. Show IP PIM RP map. Everything maps to 10.0.2.11. And even on the RP address we need it. Show on the RP device we need it. Show IP PIM RP map. Everyone has the exact same group to RP mapping. Everyone's got PIM everywhere. Everyone's got multicast enabled everywhere. Everyone's got unicast routing fully configured. We've completed the magic formula. Multicast should be working. Just trust me, right? It should be working. Well, we don't want to just go on blind faith that it's working because we're human. We make mistakes every once in a while. And so let's get a little evidence for that faith here. So how can we test this? Because in the lab, you're not actually going to have a multicast server sending multicast traffic, and then you have a client that has a multicast application that can receive that traffic. So we have to use a different method in here. And so there's a pretty easy to use method where we can just use our switches, and we don't even need clients anywhere else. So what I do is, so again, Cat1's my RP at the moment. I'm going to go to as far away from Cat1 as I can. From a layer 3 perspective, for me, that's Cat5. And so I'm going to have Cat5 join a group. I'm going to have it join group 239.1.1.1. And when it joins that group, I can actually ping the multicast IP address from any other device that has PIM enabled on it, and it should actually get responses. And that's how I'm going to do my basic testing. Is multicast routing working at a basic level? Okay, so the command to do that on Cat5, first I guess I need to pick an interface. Show IP int brief. Almost any interface will do as long as it's up. I probably don't want to use the interface that points back to the rest of the network because it's not as good of a test as if I pick an interface that requires routing, a little extra step of routing to get to. So loopbacks are awesome because they're always up type of a thing. Any of the SVIs would be perfect choices, but I'll choose the loopback. And the command is IP IGMP. We'll talk about IGMP in more detail in another video. But remember, that's the protocol that clients use to talk to their routers. But we're going to say IP IGMP join group, and then pick the IP address of a multicast group to join. Cat5 has now joined group 239.1.1.1 on its loopback interface. We should have now told the RP about this because Cat5 essentially received a join from itself and should have told the RP for 239.1.1.1, which in this case is Cat1 because it's the RP for everything, about a client that's wanted to join that. And now we should be able to go to any other PIM-enabled device, Cat1 or Cat2, and ping 239.1.1.1 and get a response, hopefully. Now, with IPv4, when it sends a ping out, it actually sends a single ping, sending one. I got a whole bunch of replies, but the reason for that is it sends it out by default all PIM-enabled interfaces, which I have a lot of PIM-enabled interfaces. And so, that's part of multicast. One packet can replicate out many different places. And so that's why I got a whole bunch of replies. I got a whole bunch of replies to this one ping because I had so many PIM-enabled interfaces that I got so many, pings going out. But it's all coming back from Cat5. Just a little tip about this. You notice when I pinged and it started replying, they replied and listed them pretty quickly, one after the other. That's because I have a command, no IP domain lookup, already pre-configured on my switch. If I don't have this command, because by default, we look up domains, IP domain lookup is configured by default, and I have to turn it off if I remember right. And let me just double check here. Show, run, include domain. Yeah, so no IP domain lookup is actually a non-standard config. What actually happens is it tries to do a reverse DNS lookup of the IP address, and if that doesn't work, it has like this 2-second timeout. And so what happens is if you ever in your own testing, because I usually have this pre-configured on my switches, but if you're own testing or in the lab, if you're doing this and you see one, and then it waits for 2 seconds, and you see another, and it waits for 2 seconds, over and over and over again, oh man, it's like pulling teeth in the lab. You're just like, oh, give me back control of my switch. That's why if you put no IP domain lookup, once it starts sending the replies, it just blasts through them real quick. I think you can, if you do a Control-Shift-6 and then X, it'll break out of that cycle, and I think it'll end it faster if you ever get stuck into that. But if you ever see that in your testing or whatever, that's why that's happening, and that's how to get around having to wait that long time. Okay, but that's what I wanted to see, and I should also be able to do the same thing over here. Do it on cat 2, let's see what happens. I get a bunch of replies on cat 2, whole bunch of replies on cat 2. So that's good, that's what I want to see. I want to see replies from this. I don't think it's worth pinging on cat 5, and I don't even know if it'll work on cat 5. If it's pinging itself, we could try. But I personally don't really reply on every last, or test it on every last device. I usually just test it on 1 or 2, and as long as I'm getting replies, I feel pretty good about my multicast config. Now, as you're doing these testings, if you do repeated testings, you may run into this. So wait a minute, it worked a whole bunch up here, and now it's not working. And I didn't change anything. Hey, now it worked again. The thing is, you might get these differing, inconsistent results, and that's actually because there's certain things going on behind the scenes that you don't have to worry about. Their natural processes, but show Ipm Route. This is the akin to show IP route for unicast. It shows all the multicast routes that we know about. If I remember right, what ends up happening is that some of these groups start getting, I think they call it pruned, and they stop sending the multicast traffic out those interfaces. Whoops, sorry. And so you might see, again, sometimes it works, sometimes it doesn't work, and don't let that throw you too much. If you want to retest and just see, do things work again, do this. Clear IP mroute star to clear out your mroutes. Do the ping again, and usually they start working again. So don't let it throw you that it worked the first time, but it stopped working, and I don't feel like I've changed anything. Just do a clear IP mroute and ping. If it then works after that, you're okay. Don't worry about it. But if you clear all the mroutes, even out of all devices, and it still doesn't work, okay, then maybe something did change, and maybe you need to start looking at that. But if it works the first time and it works after a clear IP mroute, just assume that everything's working fine. Don't worry about if it stops working on subsequent tests. So just a heads up on that one. Okay, so that's the basics right there. Multicast is fully working in my network, and I've completed my magic formula. Now, what if I want to do a little bit more advanced with the static mapping? I want to have more than one RP address, more than one RP going on. I can do that, but again, it has to be for different ranges of multicast groups. And if I want to specify ranges of multicast groups, I have to use ACLs. So let's get into that. So here will be my new design. Let's have Cat 1 and Cat 2 both be RPs, but for different things. So let's have Cat 1 be the RP for anything that starts 239.x.x.x. And this one be the RP for 224 through 238.x.x.x. Everything else. Okay, we can absolutely do that because they are RPs for different ranges of multicast groups. That's okay. How can we accomplish that? Well, let's go in and show you how to do this. So I'll start on Cat 1. In order to define Cat 1 as an RP for a specific range, we need that ACL, and they are ACLs in the 1 to 99 range, just a standard ACL. And whatever is permitted, sorry, let me give me a number. Whatever is permitted is a match. I will use that as an RP. And so I want to permit anything that starts 239.x.x.x and nothing else. So that's easy to do. I can do it with one line of code here. So permit 239.000 with a wildcard mask of 0 and all 255s. 255 would be the wildcard mask. And I guess I haven't really talked about this before, but so let me show you how to quickly come up with a wildcard mask. If you think of the normal subnet mask for something, so let's say the normal subnet mask for 239.x.x.x would be 255.0.0.0. To come up with the wildcard mask for that, you just subtract that from all 255s. And now these don't line up. Let me make them line up real quick so it looks a little bit better. So 255.0.0.0. And so if I subtract 255 minus 255 is 0. 255 minus 0 is 255. 255. 255. So that's how you can come up with the wildcard mask if you already know what the normal subnet mask would be. Super easy method for you to do that. Okay, back to the config. If it's not explicitly permitted, there's the implicit deny at the end. So this is only going to allow 239.x.x.x addresses. And now I'm just going to update my RP address command. So the RP of 10.0.2.11 is now going to be limited to ACL number 1. Whatever ACL 1 permits, that's what this IP address will be the RP for. Now we want switch 2. And the thing is with static mappings, I need to configure everything on every single device. So for switch 2, I want it to be the RP address for everything except for 239.x.x.x addresses. And so I'm going to need another ACL. So I'll do access list 2. Now with the static mappings, we can shorthand this. So let's deny 239/8. And then permit, don't worry about that, we'll fix that in just a minute. I guess we're just going to permit everything else after that. Technically we only need multicast ranges, so I guess I can do the multicast. And that would be, what, 31? 255, 255, 255. Or I believe you could just permit everything, which would be a little bit more simplistic. But I think I got that right there. We'll find out in just a minute. I didn't get it right. Dang it. There's 16 ranges, not 32 ranges. Fine. One more time. How about that? 15. That'll get me up to 240. Yep. Or right, one before. Okay, so show access list. So ACL2 is basically the inverse. We're going to allow everything but 239 from a multicast standpoint. And so I need another RP mapping command, Ipm RP address. And now I need to pick an IP address on Cat2. 10.0.2.12 is one of those with ACL2. And now if I do a show Ipm RP map, we see I have two mappings. ACL1 maps to this IP address. ACL2 maps to that IP address. And now I need to replicate this on every device. So show run include RP address, and I need my ACLs, and I need thanks log, and I need the rest of it here. Okay, so I'm just going to copy these and just paste them. Copy paste, easiest way to go. Same thing on Cat5. And now, show Ipm RP map. Everyone should be back in sync. Everyone knows that ACL1 maps to this IP address, ACL2 maps to that IP address, ACL1 is identical on every device, ACL2 is identical on every device, and now we're back in sync with everything. And so Cat1 is the RP address for 239 addresses. Cat2 is for everything else. So let's join another group on my loopback interface over here. I'm already joined to the 239.1.1.1. Let's join to IP IGMP join 238.1.1.1. So we're joined to two different groups here. I should be able to ping both of them from all the devices. Ping 239.1.1.1. Ping 238. There we go. Multicast is working for both of those, and you should be able to repeat the test everywhere. There's 238, where Cat2 is the RP for this one. Cat1 is the RP for this one. And awesome. And how can we tell which device, which RP was actually used for different things? One way that you can see that is with the show Ipm RP command. So for the groups that Cat5 knows about, or has active on it, we'll say, we see that 10.02.11 is the RP for group 239.1.1.1. 10.02.12 is the RP for group 238.1.1.1, which is what we would expect based off of the config that we had in here. This group is actually from Auto RP, which is something that we'll talk about in another video. But you'll get actually different outputs depending on which device you run this command on. If I run this command, say on Cat2, which is an RP itself, we actually get both. That's nice. We're seeing other things too. Sometimes I've seen where not every one shows up on every device, but maybe because, maybe because I did pings from the other devices, maybe that's why it's showing up. Show Ipm RP. Oh, I see here too. So that's good. I mean, everyone's in agreement that we use this IP address for the 239 address. We use the other IP address for the 238 address. And at the end of the day, that's really what we want. Everyone's using the same RP for the same multicast group, which allows everything to work as long as we have everything else in place. And that's as far as we should need to go with the static mapping. So there is the implementation of the magic formula. This is how we would do static mappings. Just whatever your mapping is, make sure that you've replicated that across all devices, and we should be good. So there we go. In the next video, we'll look at other methods to define that RP mapping.